Welcome to this lesson video. Today we'll be looking at number of moles. It's chemistry 1501. Let us start. Number of moles. This is the basic equation we use to calculate the number of moles, where n is the number of moles. The SI unit is mole, and then the smaller m, it's the mass of a substance in grams. This is the SI unit, and then m, it's the molar mass. There is a lesson video on how to calculate the molar mass. The SI unit is grams per mole. So basically, if you want to calculate the number of moles, you need the mass of a substance in grams, and then if you have the molecular formula of that substance, then it's very easy to calculate or determine the molar mass. We use the periodic table. Let us look at a few examples on how to apply this equation. Our first example, suppose we have 20 grams of sulfuric acid. Then this is the molecular formula of sulfuric acid. It contains hydrogen, sulfur, and oxygen. Then the question, calculate the number of moles in this sample. Now you start by writing the equation m over bigger M. Then n is equals to the mass is 20 grams divided by. Now we can see that we have 2 atoms of hydrogen, and then what is the molar mass of a single hydrogen is 1 from the periodic table, plus what is the molar mass of, actually we have 1 atom of sulfur. The molar mass is what? It's 32. Then plus we have 4 atoms of oxygen, and then the molar mass is 16. From here, the molar mass, actually the number of moles of 20 grams sulfuric acid, it's 0.204 mole. Let us look at more examples so that you can get used to this equation and how to apply it. Our second example is 34 gram sample of ammonia. Feel free to pause the video, work out this question, and play the video to verify your answer. N is equals to m over m. N is equals to 34 grams divided by, we have 1 atom of nitrogen. The nitrogen is 14, plus 3 atoms of hydrogen, and then we have 1 atom. Actually we have 1 as the molar mass of a single atom of hydrogen. From there, N is equals to, we have 2 mole. Let us look at another example. Our next example, we are given the mass in grams, and then the name is water. Now we all know that the molecular formula of water is H2O. So N is equals to m over m. N is equals to 25.0 divided by 2 atoms of hydrogen, 1 as the molecular formula, plus 1 atom of oxygen, and then we have 16 as the molecular formula, as the molar mass actually, not molecular formula but molar mass. this will give us 1.39 mole. This question is a bit different from the previous ones. This one we are given the number of moles and then we want to calculate the mass in grams. So in the exams or questions, don't expect the question to always give you the mass in grams and then you calculate the number of moles. Sometimes you'll be given the number of moles and then you have to work out the mass in grams of the sample. Now in this case where we see N, the number of moles, we substitute by 4,50. It's equals to M, and then we have 2 atoms of lithium. The molar mass of lithium is 7 plus 1 atom of oxygen. The molar mass is 16. And then from there we work out, we cross multiply. We are going to have M is equals to 4,50. Alright, 2 multiplied by 7 is 14. 14 plus 16, we have 30, so multiply by 30. Then from there we have 4,50 multiplied by 30, it's 138 grams. Our next equation of number of moles is this one, whereby N is the number of moles in mole, and then N, the bigger N, actually we have N and Na. The N, this one on the numerator level, it stands for substance, no, not substance, actually molecule, or the number of atoms. When the question says how many number of atoms does this substance have, think about this equation, and then Na is Avogadro's constant. Constants, and then the magnitude is always 6,02 times 10 to the power 23. The SI unit is per mole. Our first example, this question we have 23.0 mole of oxygen. How many molecules are in this oxygen? We use the equation Na, and then we are given the number of moles, which is 23.0. It's equals to N. The Avogadro is 6.02 times 10 to the power 23. Then we work out the N, cross multiply, N multiplied by 1, it's N, and then we have 23.0, 6,02 times 10 to the power 23. This is our answer. Let us look at more examples. We have sulfuric acid, which has 3.4 times 10 to the power 23 molecules. Now we need to calculate the number of moles. We have N. Remember, it's very important to start with the equation so that we can see where you substituted your given figures. And then our answer is 0.56 mole. Our next question is a bit different. This one you are given the mass of ammonia in grams, and then the question is saying calculate the molecules. Now this question is a type of a question we call a multi-step questions. So we need to calculate something before we can go straight to the actual question. So the first thing that we need to do, we need to calculate the number of moles using the first equation we talked about. We have 25.0. Now remember, one atom of nitrogen, we have 14, plus 3 atoms of hydrogen, we have 1. And then the answer is 1.471 mole. This is not the actual answer. We are not answering the question, but we are going to use this to calculate the molecules. Then we go to the second equation. One comma 471, it's equals to n over 6.02 times 10 to the power 23. N is equals to 1,471 multiplied by 6,02 times 10 to the power 23. Eight 8.853 times 10 to the power 23 molecules. This is our answer. Our next question, we are given the molecules. We are given the molecular formula. We are looking for the mass in grams. Now this question is the same as the previous one. It's a multi-step question. So we need to start by calculating the number of moles using this equation. It's 8.200 times 10 to the power 22 all over 6,02 times 10 to the power 23. Number of moles, we have 0.136. From here, we can use this equation. You are looking for the mass, and then we have 2 atoms of nitrogen 14 plus 6 atoms of iodine, which is 127. Then from there we cross multiply m, it's equals to 0.136 multiplied by this, and then we have our mass will be 107.44 grams. This is our final answer. That's it for this lesson video. This is Fahula SJ. Thank you very much.